So what we get here, we have mean equal 20, right? And variance equal to 16. And so now let us say the question is about, we want to find x is between 28 and 12, okay? There are several ways to find the probability of x between 28 and 12. And we know the variance is 16 and the the mean is 20. So let us say we don't know anything about this distribution, okay? If we don't know anything about this distribution, how can we find the probability? Okay? That would be by Chebyshev inequality, right? And what is Chebyshev inequality? We have P x minus mu x less than or equal to k sigma x, okay, will be greater than or equal to 1 over 1 k squared, right? So let us say we don't know anything about this distribution. This is the question, okay? Then how should we deal with it? We should deal with it by Chebyshev inequality. So the important thing is to find k, okay? How much should be k? So in this case, 28 is equal to 20 plus 8. Okay, 12 is equal to 20 minus 8, right? And so then k sigma x should be equal to 8, right? Okay? You have these two numbers, 28 and 12. So 28 is equal to 20 plus 8, and this one is equal to 20 minus 8. So we know k sigma x must be equal to 8. And how much is sigma x? Sigma x is equal to 4, right? So k is equal to 2. Okay, k is equal to 2. So in this case, if you don't know anything about this distribution, okay, then you use Chebyshev inequality. So what you get? That would be equal to 1 minus 1 over 4. So that would be equal to 3/4, okay, 3/4. Okay, but of course we know it is a binomial distribution, but because the sample is very large, we have 100 samples. So in this case, we want to use normal distribution as an approximation of this binomial distribution. Okay, so the same thing, we want to change, okay, we want to transform x into z. So this is equal to p, okay, z, less than or equal to 28 minus 20, right? X minus mu x, x is equal to 28, minus mu x, 20, and divided by 4, okay, it's by 4. And then the same thing here, you have 12 minus 20 divided by 4 again. So what do you get? You get probability of negative 2 less than or equal to z less than or equal to 2. So it will be equal to 9.9544. Okay? Any questions? Any questions? So we finished continuous random variable. Now we want to get to sampling. Okay, we are getting into sampling. So that's chapter 9. Okay, that's chapter 9. Okay, in terms of sampling, we know we have to use some scientific method. Okay, so if you want to, you are poll. Okay, what means poll? If you want to use poll, you want to know the sample you get really reflects the population, okay? If the sample you get doesn't reflect the population, then your sampling, okay, the result will not reflect the actual situation. So it is very important that when you do sampling, okay, the sample must reflect what's going on in terms of the population. So there's one example. In the 1960s, there's one presidential election in the United States. Okay, and of course people are interested in which candidate they're gonna choose. Okay, and so they use telephone to do a sampling. Okay, they use telephone to ask people questions. Of course, this is very common now. But you want to remember in 1960s, at that time, still very few people have telephone, okay? And for those who have telephones, they are rich men. So most likely, if they have a survey through telephone, what do they get? They only get rich people. So what does that mean? Because within this country, for the United States, there are rich people, of course, but also there are poor people. And rich people can vote and poor people can vote too. But in this case, the survey, okay, the sampling, they only survey rich people. So will that reflect the result? No. So when you do sampling, okay, you want to do the survey, you want to be very careful that really it reflects the population. So in that telephone sampling, in that poll, they get Republicans will be elected, okay? Let me briefly explain this. Basically, there are two parties in America. But you know, there are more than two parties. There are only two major parties, okay? Two major parties. One is Republican, right? Republic. So this is Republican. The other one, Democrat. Democrat. But you know, there are more than three parties. I think there are, in terms of major party, there should be four major parties. One is green. One is green. But of course, we only talk about two, okay? We only talk about, because the major ones, these two. For Republicans, usually they are rich men, okay? For the rich men, they support Republican. For the poor people, they support Democrat. So in this case, the poll, okay, they say Republicans candidate will be elected. But what happened? It happened that Democratic candidate was elected. Why? Because the survey only gets you rich people. They don't get the poor people. And as a matter of fact, in terms of number, which one is greater? Rich man or poor man? Poor man, the number is greater, right, for poor men. So they got more votes there. Anyway, so if you want to know the story, the book has a case study on this, okay? You can read a story. It's kind of interesting here. So if now someone want to do a survey using telephone, is it a good idea or not? Use telephone to do a survey, is it a good idea or not? I suppose not. Why? Because a lot of people have handset. They have cellular phone, but they don't have fixed line telephone, right? So you have handset, right? But some of you have handset but don't have fixed line telephone. So as time goes by, you know, you have to change your techniques in terms of sampling. And there are many details about sampling error and all that. But in this class, we don't have time to deal with it. So what we're going to talk about now is sampling distribution. What means sampling distribution? our goal is to find a way to relate the sample and the population, okay? Oftentimes, we don't have the time and money to do a census. That's to survey all of the targets of our study. But in this case, we don't have that time and money. So what we would do? We would do it by sampling. We only take out a portion of the population, okay? Take out a portion of that and try to find out what's going on in the sample and want to refer the sample central tendency and the sample variance, okay, to the population. So in this case, we need to have a theory to reflect this. And so this is the reason we have to study sampling distribution. And for sampling distribution, we have two types. The first one is sample sum, okay? The second one is sample mean, okay? So of course we get a portion of the population, that's the samples, and we study them, okay? And then we find out the mean of the sample and the variance of the sample and want to infer the sample mean and the sample variance to the population mean and population variance, okay? How can we achieve that? First one we know, x, for whatever distribution that is. The mean is mu x, the variance is sigma x squared. Okay, so this is what we have. And now, let us say sample sum is equal to s. Okay, sample sum is equal to s. And the sample mean is equal to x bar. Because it is sample sum, right? Okay, it is sample sum. So let us say we have sample 1, sample 2, and we have sample n. Okay? We have so many samples. And S, okay, it is a sample sum, right? So what should S be? S will be x1 plus x2 plus xn. Okay? So the question is, this is the sample sum, right? And this is the population, okay? We already know the population, the mean is this, and the variance is this. Okay? If we know all this, what should be the mean of S, okay? And what should be the variance of S, okay? So this is our question, okay? How to deal with it? Because we already know S is the sample sum. So that's the sum of all the sample, right? That's the sum of all the samples. So what is the mean of S? Very simple. It is equal to expectation of S, right? Because this is S we are dealing with, mu S must be equal to expectation of S. And what is S? S is here, okay? So we'll put all the number in. x1 plus x2 plus up to xn, right? As you may know, for whatever we choose, okay, because this is addition, right? So we can put them out like this, okay? Any questions so far? Basically, we just put S in, right? And this is a standard operation of expectation. We move all the variables out like this, okay? Okay. What should be the mean here? Because this is any sample from the population, right? So on average, what should we get? We should get mu x, right? The same thing, mu x. And this one, the same thing, mu x. So what do we get? We get n times mu x. Okay? Any questions? So very simple. If we have a variable looks like this, okay? The simple sum must be n times mu x. Of course, this part we haven't done that yet, so we have to get to this part too, okay? Then we need to find out variance of S, okay? What is variance of S? First, we need to know what is S. So S is x1 plus x2 plus up to xn, okay? Now, we haven't emphasized this yet because oftentimes if you want to have a very scientific and objective result in terms of sampling, your sample must be independent, okay? The sampling must be independent. So if it is independent, will there be any relationship between x1, x2, and up to xn? No. So what does that mean? That means the covariance of x1, x2 must be equal to 0, right? Okay, so what is this? This will be Vx1, okay, plus Vx2, and plus Vxn, okay? And plus 2 summation covariance. Let me see what's going on. So forget about these two, okay? Forget about these two. It must be summation covariance xi xj, okay? I, j, and I is not equal to j. So this is kind of hard to explain it, but just take it for granted, okay? Take it for truth, okay? Think about it, okay? If you want to deal with it, you know, you want to try some algebra, okay? So just believe me, okay? Just believe me, this is correct. But we know this part is equal to 0, right? Because we say the sampling is independent, so we can forget about this. Okay, simply we can forget about this. Okay? So what is this? This is equal to sigma x squared, right? And this one is also equal to sigma x squared. And then plus sigma x squared. So how much should that be? That should be n times sigma x squared. So if you know the population has a mean of mu x, variance of sigma x squared, then the sample sum must be n times mu x and n times sigma x squared. Okay? We already proved this. You just remember the formula, it will be just fine, okay? When you do the problem, you don't have to go through the whole process again. You just remember this formula. Okay, so now we are done with this. But then the second question is, this is sample sum, right? We haven't done with sample mean, okay? So we also want to find out what is the distribution of sample mean, okay? It should be mu x bar, right? And it should be sigma x bar squared. But then we have to find out what's going on here, okay? So what is x bar? X bar is sample mean. So that is equal to 1 over n times S. Because this is sample sum, right? This is sample sum, and divided by n, you get sample mean, okay? Okay, so the same thing here. What we are going to find out is what is the mean of x bar. So that's mu x bar. The same thing, it is equal to expectation x bar, right? Okay? and that will be equal to expectation 1 over n times s. Okay? And then in this case, you move 1 over n out. 1 over n and expectation s. Right? Do we know this? We do, because we already found it out. It is equal to n times mu x. So 1 over n times mu x. So what do you get? You get mu x. So from this, we know mu x bar is equal to mu x. Okay? Any questions? Okay, then, of course, after we find out the mean of x bar, we want to find out the variance of x bar. Okay, so then let me try here, okay? We want to find out variance of x bar, okay? Of course, you know x bar is equal to 1 over n times s, right? Because that's what the question says. This is sample mean. So it should be true here. Okay, the same thing. Now, I want to move 1 over n out. Okay, I want to move 1 over n out. What should it be here? Zhang Yuli. If I move 1 over n out, what should be the number here? She's not here? Okay, what about you? So 1 over n, I want to move 1 over n out. How much should it be? It should be 1 over n squared, right? Okay, so that sounds good because we already know this. We already know this. So that will be 1 over n squared times n times sigma x squared. So that will be equal to sigma x squared divided by n. Okay? So we find out mean of x bar. We also find out variance of x bar. That is equal to sigma x squared divided by n. Okay, any questions so far? So this, in terms of the whole process, it may be a little bit difficult, but in terms of formula, it's just easy. If the population, the distribution has a mean of mu x and variance of sigma x squared, then what about the simple sum? The simple sum will be n times mu x, n times sigma x squared. Okay, that's the variance, that's the mean. And for simple mean, that will be mu x, sigma x squared divided by n. Okay, so this is the formula you need to remember. Okay. Any more questions? Okay, let's get to the next part. Okay, now we have 3 numbers. So because we say there are only 3 numbers, so how should we treat it? It should be treated as population, okay? So this is the population we have. We only have 3 numbers, okay? And now the question is, independent random sampling choose 2 samples. And find So there are only three numbers, 50, 100, and 150, okay? And you use independent random sampling. You choose two samples out of it, two samples, okay? And find out the mean and variance of sample sum and sample mean. So in this case, basically what you're going to do, you have to choose one sample first and then return this sample to the population, okay? You choose one and then return it and then choose again. Okay, so then how many possibilities there? Okay, so how many possibilities there? So first one you will choose, you may choose 50, right? Okay, you choose one and return this to the population and choose again. So the first one you may get 50. What about the second one? The second one you may get 50, 100, and 150, right? Okay, so it's like cast a coin twice, okay, cast a coin twice, but now it's not a coin, okay, you have three numbers. So then you want to choose two from this population, okay? You put one, I mean there are three numbers, you get one, okay, and then you put it back and you try to get one again. So you get two samples, okay? So the first one you may get 50, and also you may get 50 again. But then also you have it is also possible that you get 100, 150, okay? The second the other possibilities are that you get 100, right? And also you get 50 and 100 and 150. Okay, the same thing. You may get 150, get 50, 100, 150, right? So basically, if you have a population, okay, with number n, so let us say this is the size of the population, okay, this is the size of the population, and n is the size of the sample, okay, n is the size of the sample. If the number of population is big N and the number of sample is little n, okay, then what you get, this is the possibility. Okay? So in this case, you have three numbers. And how many samples do you get? You get two. So there are how many different samples? 9. Okay, 9 different samples. Okay, so this is a basic outline of these whole questions. You first figure out what are the samples, okay, what are the samples. But if you know the formula we just talked about, we know if the variable is x and the mean is mu x and the variance is sigma x squared, then the sample sum should be n times mu x, the sample variance should be n times sigma x squared, and the sample mean should be mu x, and the variance of sample mean should be sigma x squared divided by n. Okay, so there's one way to deal with it is to figure out all the samples, right? Figure out all the samples. And then from here to deal with sample sum and sample mean. But since we already derived the formula, right, we can simply use the formula. But before you apply the formula, first you have to calculate the population mean and population variance. Okay, so x, if it is equal to mu x and sigma x squared, then sample sum should be easy, right? Should be n times mu x and n times sigma x squared. And then x bar should be equal to mu x times sigma x squared over n. Okay? But first we have to calculate this because we don't know this yet. Okay? So mu x is equal to 50 plus 100 plus 150, okay? divided by 3. So how much should it be? 100. Okay? And then let us get to sigma x squared. Remember, because in this case we say there are only 3 numbers, and we are dealing with these 3 numbers. So that is the population, okay? So it should be 1 over n, right? And here it is 50 minus 100 to 2's power, a square, okay? And then 100 minus 100, and plus 150 minus 100. Okay? Any questions? And n, how much it should be n? It should be 3, right? We have 3 numbers, okay? So there will be 3, and then this is this plus this. So it should be 5,000 divided by 3, okay? 5,000 divided by 3. So we already know this one is equal to 100 and 5,000 divided by 3, right? Okay? So what should be here? It should be equal to, can anyone tell me what should be here? It should be equal to, because little n, how many samples you choose from that? You choose 2, right? So that would be 200. And then here it will be 2 times 5,000 divided by 3. Okay? And what about x bar? It should be 100, right? And what should be here? It should be 5,000 divided by 3 and times 1/2. Okay? So if you know the formula, it's very easy. You don't have to get all the different samples and calculate it from there. No, you don't have to, because we already derived the formula. You simply apply those formulas and you get the answers. Any questions so far? Okay, let's get to a different questions. Okay, this is the population. Okay, the distribution is a standard normal. It is standard normal distribution. You have 0 and 1 here. And now we get 10 samples from this population. Okay, we get 10 samples. And what is the probability that the sample sum is between 94 and 106? I think I get something wrong here. It should be 10. So it is not a standard normal. It is 10 here, okay? It is 10. Okay, so how should we deal with it? We know x, right? But we don't know s yet. We know x, but we don't know s yet. So in this case, if s is a normal distribution between 10 and 1, I mean mean 10, variance 1, okay? Then what should be S? Can anyone tell me what should be S? Okay, this gentleman, what should be here? the mean, how much should that be? 100, right? And what about variance? Is equal to 10. Okay, good. So in this case, you have to translate the whole question into a formula. Okay. So what should that be? Okay, you need to know the probability of S less than or equal to 106, greater than or equal to 94, right? Because this is S, what we need to know is Z, because the only thing we have table is Z. So you have to change this into Z. So PZ, it should be 106 minus 100, right? Because mu is here, okay? And then divided by square root of 10. This is variance, right? This is variance. It should be standard deviation here. Okay, because in this case, the calculation is a little bit difficult, right? You just use a calculator, you should be able to find it, okay? So then you find a number here, okay? Z1 and then Z2. Of course, this one should be negative, right? This one should be negative. And so then from here, you should be able to get the result, okay? Let us get to another question. Another question say, okay? If I get 25 samples, okay, now I get 25 samples, what's the probability? What's the probability that sample mean is between 9.6 and 9.4 and 10.6. Okay? And this question, because it is a sample mean, okay? It is sample mean, so you have to find it. Sample mean, okay, will be, how much should it be? So your turn. What should be here? How much is it? 10, right? And what should be here? The variance. Louder. Are you sure? So your turn. What should be here? So it's 1 divided by 25, right? I can't quite hear you, so anyway. Then it's 0.02, okay, 0.02. Okay, the same thing. This is the probability we need to find out, okay? So we need to find P S star, okay, between 10.6 and 9.4, okay, 10.6 and 9.4. So what should that be? P Z, right? Greater than or equal to 10.6 minus 10, and then you have to divide it by 1/5, right? 1/5. And here, 9.6 divided by 10, minus 10 divided by this. Okay? So the same thing you get the Z, you get Z1 here and Z2 here. And of course this is a negative number, right? So then you should be able to find the probability. You check the table, find a corresponding Z, and find a corresponding probability. So you get the probability there. Any questions so far? Okay, we'll stop here.